Okay, I'm going to start some of these problems from section 2.4 in the AP Calculus book. These are on the chain rule. 53 is an interesting problem because it employs an identity that a lot of people do not remember. This is a product, so I'm going to do a product rule. I'll bring down the sine of 2x times the derivative of cosine, which is negative sine of the same angle, times the derivative of the angle, plus the other way around. Bring down the cosine of 2x times the derivative of this part. The derivative of sine is cosine, same angle, times the derivative of the angle. So this is negative 2 sine squared 2x plus 2 cosine squared of 2x. Cosine times cosine being cosine squared. If you were to write it in the other order, the cosine would become first and the sine squared would be second. If you were to factor a 2 out, you would have cosine squared minus sine squared, which is an identity that, again, a lot of people tend to forget, and that is the cosine of 2u is equal to cosine squared minus sine squared. Cosine there's a few of those, but that's one of them. So this right here could be, this right here could be called the cosine of, these were 2 x's in here, weren't they? So when you double it to 2u, those would become a 4x. So the answer, I believe, in the book is 2 cosine 4x. I probably wouldn't hold you to knowing that identity, but if it's a multiple choice test and there's only one correct answer, and this is the one they choose to use, you might be best served knowing how to simplify it. Okay, after 53, I was asked 55 and 57. We could do it as it sits. We could try to simplify it into sines and cosines. It's kind of your choice. I know that cotangent is cosine over sine. Cosine over sine. If you're dividing by sine, that's the same as multiplying by 1 over sine. So I might rewrite this. I don't know. You don't have to, but now it would be cosine over, what's sine times sine here? Sine squared. So I just wrote it in sines and cosines. I wanted to see if it simplified. It did not simplify. I don't know if it's easier this way or from the original. So either way, it's a quotient rule. Are there any preferences? I find people know the derivatives of sines and cosines better than they do the other ones. So the bottom times the derivative of the top, derivative of cosine is negative sine, same angle, times the derivative of the angle, minus the top times the derivative of the bottom. Derivative of sine squared, you do power times base to the 1 less power times the derivative of base. Derivative of sine is cosine, same angle, derivative of angle. All divided by the bottom squared. What I did was I did a quotient rule. U over V. This is V, this is U prime, minus U. This all is V prime, all over V squared. So I'm basically doing the quotient rule. So what does this give me? Negative sine to the third, I believe. And because sine times sine squared would be sine to the third, minus 2 sine x, cosine squared x, it looks like, cosine times cosine, and this is all now over sine to the fourth. Can you factor a sine out of the top? Or even a negative sign, I don't know. If I take a sine out, what would I have on top? You would have a negative. Let's take the negative out just to make them positives. So if I take the negative out, would that leave me with sine squared minus 2 cosine squared? And sine to the fourth could be written as sine times sine to the third. these could cancel, giving me apply the negative on the top to reverse the subtraction perhaps, and you'd get 2 cosine squared of x minus sine squared, of x, all over sine cubed of x. Now this could be written in different ways. I'm going to see what the book has. Give me a moment. I have a feeling they might have done the quotient rule from the original. You're right. If I took the negative out, right in here should be a plus because I did take the negative out. You're right. Okay, that answer should be numerically equivalent to theirs, but I'd like to try the quotient rule from the original. So let's try the quotient rule from up here and see what happens. If I was to do the bottom times the derivative of the top, derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, same angle, derivative of angle. Minus, now you have the top times the derivative of the bottom. Derivative of sine is cosine, same angle, derivative of angle. All divided by the bottom squared. The bottom squared. So, what do we have here? We have sine of x times cosecant is 1 over sine squared, isn't it? Cosecant is 1 over sine, but because it's squared. Minus, what's cotangent? Cosine over sine, right? Times cosine, and this whole thing is over sine squared. This first one is going to simplify to what? Negative 1 over sine. Here you're going to get cosine squared over sine, and it's divided by sine squared. Can I write the top as a single fraction because they now have a common denominator? You'd have negative 1 minus cosine squared divided by sine. And how do you divide by sine squared? You multiply by its reciprocal. And now we match the answer they had in the book, negative 1 minus cosine squared, all divided by sine to the third. So they obviously took the derivative from a quotient rule from the way it was originally. So then you get this answer. Okay, 57 now. To find the derivative of y, you would call it dy dx. Guys, you may or may not know this. In the next section, we're going to learn implicit differentiation. You are already doing it. What's the derivative of the left? Dy dx. What's the derivative of the right? Well, you keep your constant out. You would do power, because you got to remember, secant squared means this, right? So power, base, 1 less power, derivative of base. What's the derivative of secant? Secant tangent of the same angle times the derivative of the angle. So, the answer for this derivative is going to be 8. Secant times secant is secant squared, and then times the tangent. And that would be dy dx. Okay, after 57, we jump to 83. It looks to me like a product rule. So I'll bring down the first one, the e to the x, and I'll take the derivative of this part. Derivative of sine is cosine, same angle, derivative of angle. Derivative of cosine is negative sine, same angle, derivative of angle. Plus the other way around. Now I bring down the sine plus cosine. And now I need the derivative of the first one, e to the x. Derivative of e to a power is e to the same power times the derivative of the power. So, what do we have here? Can I factor out an e to the x out of the whole thing? That would give me cosine x minus sine x plus sine x, which would cancel, plus cosine x. Cosine plus cosine is 2 cosines. So the answer they're going to have is this. Okay, after 83, somebody asked me 89. It would be advantageous to know your logarithm rules, such as the log of a times b could be broken into log of a plus log of b. How about if you had log of a to the b power? Can you pull that exponent out front and call it b times the natural log of a? These are the two properties I plan on using in this problem. First off, I'm not going to take the derivative, so I'm not writing dy dx. I'm going to write it as a log plus a log. And the square root is a 1/2 power. Now I'm going to still not take the derivative, so I'm still not writing dy dx. But I am going to use this second property and pull this exponent out front. So I'm going to have a 1/2 natural log of x squared minus 1. We're going to hit a whole section on what's called logarithmic differentiation, where you really need to know your logarithm properties. And this is what I use two of them first. Now, the derivative of natural log of u is 1 over u times u prime. Some people call it u prime over u. So if this is a natural log of u, the derivative of x is 1, right? So u prime would be 1 over x. At this point, I am taking the derivative, so I'll mark it as dy dx. Can anybody do u prime over u for this one? U is the bottom. U is x squared minus 1, right? What's u prime? What's the derivative of x squared minus 1? 2x, which very conveniently allows you to cancel those 2's. So you get 1 over x plus x over x squared minus 1. To add or subtract fractions, it takes a common denominator. You can always get that denominator by multiplying the two denominators. So this first one, what does it need? It has the x, but it needs the x squared minus 1. So when I multiply on top, I get x squared minus 1. This other one needs what? It needs an x, I think, to make the denominator. And x times x is x squared. X squared plus x squared is 2x squared minus 1 all over this. Let me make that a little clearer. X squared minus 1. Okay, after 89, I was asked 93. 93 is another quotient, so we're going to do another quotient rule. dy dt in this case. The bottom times the derivative of the top, which is u prime over u, minus the top times the derivative of the bottom all over the bottom squared. Again, it's a quotient rule. U over v becomes v u prime minus u v prime all over v squared. So what happens here? What's t squared over t? Is that just a t minus 2t ln of t, t to the fourth? Can you factor a t out of the top? If you did, you'd have this. If you factor a t out of the bottom, you'd have that. And it allows the t's to cancel. So one answer might be 1 minus 2 natural log of t over t to the third. Another answer might be this. I'll also mention that technically, you're supposed to take the natural log, you put absolute values, because that makes it positive, and you can only take logs of positives. Why did I not need absolute values down here? Because it's already squared. So I think you'll find the textbook answer is one of these. Is everybody okay with the property that allowed me to put this up top to get this exponent? Yes. Yes. After 93, I was asked 95. Again, I'm going to use properties. So I'm going to rewrite this as the square root is a 1/2 power, so I can pull the 1/2 out front. Normally, I would do this all in one step, but I don't want to lose anybody. So this becomes natural log of the top minus natural log of the bottom. So now I have this in what's called expanded form. I use the properties to expand it. I have not taken the derivative. Now I'm going to take the derivative. And I'm going to do u prime over u and u prime over u. Because that's the derivative of natural log of u is u prime over u. So that's what I'm following, is that rule. Now, when you add or subtract fractions, you need what? A common denominator. What's x plus 1 times x minus 1? Could be this, right? What is the first one missing on the bottom? It's missing an x minus 1. What is the other one missing on the bottom? It has an x minus 1. It needs a x plus 1. So don't forget to use parentheses when you subtract. So, what do I have on top? I think x minus x is 0, negative 1 and negative 1 is negative 2. These 2's could cancel, and that negative could be applied on the bottom to reverse the subtraction. So I believe this is the answer they're going to have in the textbook. Okay, number 95 leads us, and I guess that's all that I was asked. I hope these help. Good luck.